I don't wanna grow up, I'm a curious kid. The world has 100 questions I can play with. So I'll open my arms and eyes and wonder every day till the day I die.
All right, let's see. I'm excited to introduce Dr. Anne Friedlander. She is Adjunct Professor in Human Biology at Stanford University. She has broad research experience in the areas of enhancing human performance, physiology in extreme environments, and tonight's subject, using physical activity to promote healthy aging. Anne grew up here in the Bay Area, quite near Wonderfest's home in the North Bay. She earned a bachelor's degree in biology at Wesleyan University, and master's and PhD degrees in exercise physiology from UC Berkeley. Go Bears. And then she spent 4 years at Stanford Medical School doing postdoctoral work in metabolism, endocrinology, and geriatrics. For decades, she claims, Dr. Friedlander has taught exercise physiology classes at Stanford and beyond. She also consults regularly with companies that develop new fitness and wellness products and programs, even small companies like Wonderfest. Please welcome Wonderfest's newly appointed health czar, Dr. Anne Friedlander.
Thank you, Tucker. It's a pleasure to be here. And I have to say that when Tucker invited me to speak and the name of your organization is Wonderfest, I had to say yes, because I love that name. And I love that it sort of instills that sense of wonder and awe, which is the way I feel about science. The deeper you dive, the more amazing science can be. And so I really appreciate that sentiment. And I also appreciate the idea of science communication, which is something that I emphasize in my classes at Stanford as well. So let me share my screen here and we will get started. So what I'm talking about today is body hacking using exercise physiology to slow aging. And I picked the name body hacking because I think it fits for exercise physiology. So let me just start by saying it's body hacking for the sane, right? So if you look online for body hacking, there's all this crazy stuff about injections and artificial limbs and green goo and everything like that. But my goal is really to give you tools today that you can leave this talk and use right away, this evening, tomorrow, in your life to make your life healthier. And the definition for body hacking is to manipulate a biological system to obtain a desired result, right? So that's what physical activity is. You're manipulating multiple biological systems simultaneously to get a result, whether your result is health or longevity or fitness, running a marathon, six-pack abs, whatever it is. It really is do-it-yourself biology. And it's a shame that we consider physical activity a hack because it used to be a major part of our lives. We integrated physical activity into our lives. And there's a professor at Harvard called Daniel Lieberman, and he is a paleoanthropologist, and he popularized the idea that we were born to run, right? That we had this ability as endurance animals and we could run down our prey until they keeled over from heat exhaustion and then bonk them on the head, and that was dinner. He's since somewhat modified that idea, and he really says now that we are born to survive by expending as little energy as possible. So we are really good runners. We're great endurance athletes, but in our evolutionary history, it doesn't make sense that we would be running just for the sake of running, because those are calories that we'd have to get back. So we're really based on this idea that we want to conserve energy and we want to be as sedentary as possible. So that's fine when you have to go out and get all your food and your water and build your shelter and things like that. But in the modern world, of course, we don't have that built-in physical activity. We can go to the corner store and get as many calories as we want very easily. And often those calories are nutrient spare and very dense in calories, right? And it's not just the food elements. We've also engineered physical activity out of our lives. So we have screen time and we have escalators instead of stairs, and we sit in our cars to get around. And we don't even go and forage in the mall anymore. We actually order things online that then arrive at our doorstep. And so we're always engineering this activity out of our lives. And so it seems to be getting worse. We're kind of going the wrong direction with this trend in terms of our health. So here's a quote from the New York Times a couple of years ago. If you're making the customer do any extra amount of work, no matter what industry you call home, you're now a target for disruption. And what that essentially says is that we all want to sort of have this, somebody's typing in the background. I don't know if that's you, Tucker.
No. I muted that person. I think they understand.
Okay, thank you. So what it's saying is basically we're all striving to be more sedentary, and that's what we're looking for in our new products. And here's one example that came through in my Indiegogo mail feed, and it's an automatic sliding pet door. And so your dog comes up and has a little chip on its collar. It comes up to the door opens, the dog comes in. And, I think this is a great idea. I have a dog, it's only you don't want to get up and keep letting it in and out when it can't decide whether it wants to be in or out. But what I was really struck by were the comments about this device from the users. I never have to get off the couch again. Yay! That's what we're all striving for. But it has negative impacts on our health. And this sort of bleeds over into our work as well. So if you look at agrarian societies, like the Amish, they average 48 hours per week of work movement. In the modern office, it's about 2.7 hours per week of work movement. So that's a major difference. And I was working on a study at the Stanford Center on Longevity where we were tracking during COVID what was happening to people's behaviors. And of course, we have a lot more Zoom meetings, right? Like I would be normally in front of you, pacing up and down this stage, and you would have maybe walked over to this wherever we were having this meeting. But now we sit in front of Zoom and we can not leave our chairs all day. So we found that for those that could work at home 100% of the time, 65% of them increased their sedentary time by greater than 2 hours a day. So we'll find out what that means in terms of physiology later in the class, but it will have a negative impact on health. So what do? Well, we compensate with exercise. And exercise is a physical activity that is planned, structured, and repetitive for the purpose of conditioning the body or for health, for wellness. And it really is a modern construct. As I mentioned, you'd never have hunter-gatherer tribes going out for a 5-mile run for the sake of exercise. That would be extra calories that they have to gather in the field. So it would be unheard of. But now we integrate this exercise into our lives. We will pay money to go to a gym. We will use power to walk on a treadmill. We will work out, cheek to jowl inside to try and get our exercise. And I had this friend that I used to go to the gym with, and she would drive around and around in her car looking for a parking place that was close to the gym so she could get out and then walk on the treadmill in the gym. And when you think about that or you say that, it sounds kind of ridiculous. But the weird thing is, I actually get it, right? So we have compartmentalized exercise in this separate thing that we do, and then we really don't move much for the rest of the day. We have the rest of our lives. And our health and the planet and the climate would be a lot better if we could integrate those two things back together like we used to have. So because we're not moving in our daily life, various organizations have put together guidelines, so exercise and physical activity guidelines. And we'll talk about what those guidelines are a little bit later. But the problem is that many people don't meet these guidelines. And if you look at various statistics, they vary somewhat, but about 20% of US adults fully meet the guidelines, meaning 80% don't actually meet the guidelines. And there are lots of reasons for this. There are time constraints, responsibilities at home, motivation, but a lot of it comes down to this genetic inherent history of ours to be as sedentary as possible. And so when I talk about exercise to some people, this is the response that I often get. Wow, exercise, really anything but that. I thought you said extra fries. And so it's hard to integrate that into people's idea of what they should be doing. And it's too bad, because physical activity is really the healthy aging pill. There are so many benefits associated with it and so few side effects that if you could put it in a capsule, and believe me, people are trying and they're getting closer, if you could put it in a capsule, it would be the most widely prescribed drug on the planet. And here's an example of some of the things that we know that physical activity benefits, right? So in the body, in the brain, even down to the cellular level. And we're not going to have time to talk about all of these things today. We'll pull out a couple examples, but we not only know that physical activity benefits it, we know why, we know the mechanisms, we know how much. And so we're really sort of teasing apart what the essence is, what the critical elements are of exercise to get the improvements in these areas. So if you look at the literature on aging, it can be a little depressing, right? So you look at the papers, and as people age, their endurance goes down and their strength goes down and their function goes down, and that leads to a decrease in physical activity. There's a genetic role, and then energy expenditure is down, so obesity goes up, and all of these risk factors and diseases increase here. So insulin resistance, cardiovascular disease, and you get a fall in cognitive function. So yeah, pretty grim. But when I look at this diagram, I see it with great optimism, because right in the center of all of those components is physical activity, this modifiable thing that you have control over, that if you flip that arrow, if you flip that physical activity arrow, then all of these other arrows can switch as well. Your endurance can go up, your strength can go up, your function goes up, and you decrease all the risk for these diseases, and cognitive function will increase. So this is a power that you have. It's a superpower right in the center of your physiology. And so 85 years old can look very different. It can look like this gentleman here, who's in a nursing home and dependent on others for all of his activities of daily living, or it can look like Alma Kent here at 85 running the London Marathon. Now, if I were to ask you who you'd rather be like at age 85, I'm sure you'd all pick Alma, out there doing your thing, smile on your face, running your marathon. And there are a lot of things that can send the trajectory of your life one way or the other, and some are out of your control. You had bad genetics, injury, certain diseases, but there are also a lot of things that you can do, that you can control to move your trajectory away from this gentleman and more towards Alma Kent. And so we call that healthy aging. And physical activity, of course, is one of those major things you can do, and the one that we're talking about today. So for the rest of this talk, I'd like to cover these different items. So we're going to talk a little bit about common sense stuff. So this is what you can imagine around functional capacity and exercise. But then we'll go into some nerdy science stuff, which you wonder components will really enjoy. So nerdy science stuff that maybe even will blow your mind. And then we'll go and we'll talk about what's the minimum and maximum amount of physical activity to promote health. So there may actually be a maximum as well. And then I'll share some recommendations for training for performance versus training for longevity. And those two things are actually different. All right, so let's start with the common sense stuff. Well, as I'm sure you're all aware, if you're physically active, you can improve your functional capacity, right? So whether that's, training for a marathon, you can get faster, your cardiovascular fitness will go up, or doing a resistance training program, you will get stronger, right? So that's very intuitive. So we're going to take a little deeper dive into a couple of those elements, and then we'll move on to the nerdy science stuff. So the first element I want to talk about is maximal oxygen consumption. So the maximal amount of oxygen your body can use. And that is going to be proportional to the amount of work you can do. So if you have a higher Vo2 max, you can do more work. You can run faster. You can bike faster. And the reason it's the gold standard for cardiovascular fitness, as it says here, is it takes into account all of these different components of your cardiovascular system. So ventilation, bringing air in and out of your lungs, diffusion, the movement of oxygen from your lungs into your blood, saturation of your hemoglobin in your red blood cells, the picking up of that oxygen, the sending it through the heart and then out the other side, so cardiac output, blood flow down to the tissues, the removal of that oxygen at the tissues, so extraction, and then the use in the mitochondria to power your metabolism and the work that you can do. So optimizing all of these components will increase your Vo2 max and increase your functional capacity, or the amount of work you can do. So what happens to VO2 max with age? Well, here we have a graph from Tanaka and Seals, and we have VO2 max on this side, and then the lifespan here. So this is a cross-sectional study. So each of these individual dots is a person at that age. And there are two groups. They're the black dots, which are the endurance trained subjects, and then they're the open squares, which are the sedentary participants. And the first thing you'll notice is that VO2 max goes down with age. So your ability to use oxygen and to perform work goes down with age. So not a big surprise there. But it's also important to note how much variability there is around these lines. So this 75-year-old has a VO2 max that's higher than this sedentary 30-year-old or this sedentary 25-year-old. So age is a factor, but it's not the only factor that impacts your VO2 max. You may also see a slight convergence in these lines as you go down. And that has to do with the fact that the physiology is changing, but there's also probably a little bit of detraining that's going on as well in this situation. So as you get older, it's harder to train as hard as you used to. You need a little bit more recovery time, and it's a little bit harder to push yourself. You're more injury prone. And so there's some detraining happening as well. So if I ask the question, who will notice the fall first, you might answer correctly that it would be the endurance trained subjects, because they're out there doing their thing, right? They're pushing themselves. They're noticing that they can't run quite as fast as they used to, or go up the hills on their bike as much as they used to. And it's kind of pissing them off a little bit, but they're noticing that things are changing. This group down here is sort of blithely going about their business, not realizing that they're on this trajectory of decline as they're getting older. And this is important because there's a threshold of disability here at about 18 mils of kilogram per minute, below which it would be very hard to take care of yourself, that there's be a loss of independence here. And the important thing to notice here is that none of the endurance trained people cross below that threshold of disability, even though they've been declining. This group, however, has people crossing that threshold of disability as early as maybe 58 or so and getting pretty close. So these people are going to suffer more and end up in a situation where they're going to need others to take care of them. But it's not just about function. There's this well-established relationship between exercise capacity and all-cause mortality. So here's a study done at the Palo Alto VA with 6,000 vets, all male, and half of them had cardiovascular disease. And they did a treadmill test to see what their exercise capacity was. And then they followed them for an average of 7 years and saw how many people died in that period. They divided the subjects into quintiles of fitness. So the most fit up here and the least fit down here. And whether the subjects were normal or they had cardiovascular disease, you can see this exponential increase in all-cause mortality, so risk of death. So that in the least fit group, they were 4 to 4.5 times more likely to die than the most fit group in that follow-up period. So there's a well-established connection between this physical capacity, this aerobic capacity, and all-cause mortality. You see a similar pattern with muscle and age. So this is sort of a synthesis of literature values with untrained in red and weight trained in blue. And this is knee extension strength and over the lifespan here. So you can see that those that are weight trained, they start stronger, they fall less quickly, and they stay above what would be a threshold of disability there and maintain strength into their later years. And I love this study because it shows that you really can gain strength at any age. So I picked this study not because it's new, but because it has the oldest mean age group that I could find with subjects. So frail elderly men and women in a long-term care facility with a mean age of 90 did 8 weeks of high intensity resistance training, and their quadricep muscle strength increased by 174%, their mid-thigh muscle area by 9%, and they had this increase in gait speed, stair climbing power, balance. And they also had an increase in spontaneous activity levels. So you also often see this when people get a little stronger, a little bit more confident, there'll be this spiraling up of activities. On the same side, if someone falls and has on the other side, I should say, that falls, has an injury, ends up in the hospital, there can be this spiraling down as well in confidence and movement. So the bottom line here is that you're never too old to benefit from exercise, and nothing so far is as effective at reversing muscle loss as resistance training. And strength training is really important for everyone, but it's especially important as we age, because when we're young, a lot of our activities are sufficient to maintain our strength. So the hormone mix is different, their stem cells behave differently. As we get older, it's harder just to naturally maintain that strength. So lifting weights later becomes more important. And all of these things come, it's not just about getting stronger. There's an increase in longevity, reduced systemic inflammation, all these different things. And so resistance training is really emerging as a countermeasure to disease as well. And resistance training doesn't have to be going to Gold's Gym and pumping iron. It can be anything where you're pushing against a resistance more than you used to. So it can be exercise bands, it can be push-ups, it can be sit-ups, it can be using your body weight, but just trying to push your muscles sort of out of your comfort zone to get stronger. Okay, so I think that was sort of what you might expect with physical activity and the response, but let's dive a little bit into the nerdy science stuff. So it just is amazing to me that you can go out there and move your muscles, and it has an impact on your brain and your disease risk and your mitochondrial health, and even down to your telomeres potentially. So your cellular aging mechanisms are impacted. So how is that working? Well, there's a lot of crosstalk between systems. And the one I want to talk about today is the fact that your muscle actually serves as a pharmacy, right? So it is releasing substances that are being read by the rest of your body. And these substances are called myokines. So there can be hormones or proteins, and they are released in response to exercise and just throughout the day. So about 20 years ago, the first myokine was discovered, IL-6. And now, depending on who you ask or what species you're including, there's somewhere between 650 and 3,000 of them. We only really understand a small percentage of what they're doing and how they work. The ones that are released during exercise are sometimes called exerkines. But these substances are being monitored by your body. It's sort of like Santa keeping an eye on you. Have you been naughty or have you been nice? Have you been physically active or sedentary? We know we're keeping an eye on things through these myokines that are being released. So this figure, I don't mean to sort of freak you out, but this is believe it or not, a simplification of something that's happening when the muscle starts contracting and moving. So all of these things here are myokines. And the reason I put this up there is just to show you the breadth of the response. So these things feed back and impact the muscle themselves, but also impacts brain and visceral fat and how your fat cells behave, and immunity and adrenal glands and your intestines, your microbiome, your pancreas, your liver, your bone, your vessels, and even your skin. All of these are responding to the movement within your muscles. And they work through a variety of mechanisms, some not yet discovered, but one sort of overarching theme to them is that they are anti-inflammatory when you're talking about exercise and myokines. So let's dive a little deeper into that. So what do we know about inflammation per se? Well, targeted acute inflammation is good. So you sprain your ankle swells up, all of these immune cells come in, they're breaking down the damaged tissue, they're laying down new tissue, and it's part of the repair process. And then eventually that swelling will dissipate and your ankle will be better off. But systemic chronic inflammation is bad. And systemic inflammation is associated with many diseases like cardiovascular disease, type 2 diabetes, cancer, dementia, etc. Obesity and sedentary behavior and poor diet increases systemic inflammation, but physical activity increases the acute inflammation, during the exercise immediately after, but then decreases this chronic inflammation through these changes in exerkines that we associate with disease. So what does this mean? Well, I'll run you through a little scenario here to help illustrate this point. So during COVID, we were all sitting a lot, as I mentioned, and so maybe you were more sedentary than usual. And so you might have had this background elevation in your myokines, so high systemic inflammation. An analogy might be that during COVID, you had teenagers home and they had all this energy. They were bouncing off the walls. They had no place to go. You know, they had their dirty underwear everywhere. The milk cartons are on the table. The TV's knocked over. You're just, you know, we got to send this energy somewhere. Well, that's kind of how your systemic inflammation is acting. But then you've been through this class, the body hacking class. So, you know, you need to get up and move around, either interrupt your sitting or go for a walk or run. And so during the exercise, you release these myokines, and there'll be many benefits to that. We'll talk about one in a moment. But if it's a new type of exercise, maybe there'll be a little micro damage to your tissues, there'll be a little oxidative stress. And so this acute inflammation will be elevated in response to the exercise. And so then you go into this period of afterburn where your metabolism is elevated. And in that period, you're restoring homeostasis, or the balance within your body. And so the circulating myokines will fall as they're more directed towards repair of slight damage, your DNA, your mitochondria, your tissues, whatever. And so it's kind of like your teenagers are now being sent out. They finally get to leave the house. They get to play in the soccer game. They're taking all their energy and they're directing it towards scoring goals. They're being productive. They're doing well in the game. Everything's going well. And they're focusing that energy somewhere. And while these systems are activated, other types of repair are taking place. So, you know, you see a little damage on the mitochondria over there. Well, while I'm in here fixing things, why don't I just go repair that as well, even if it wasn't just from that particular exercise bout? And it's as if you have the contractor into your house and there's a hole in the wall. You want him to fix the drywall. And so he cuts out that piece and he looks inside and says, oh, yeah, well, you know, I'm sorry, but you have dry rot and your foundation's not up to code. So while I'm in here, I may as well fix this, right? It'll be an extra 5K. So your body is going through and it's fixing any kind of damage that it finds during this process. So your old mitochondria become new and regenerated. And so then you go into the recovery adaptation period to get your system ready for next time. And since you've expended that energy, now your lower resting systemic inflammation's down and you have decreased disease risk. So your teenagers come back to the house, they've expended their energy, they're all mellow, they're doing their homework, they're doing their Zoom, all is well with the system. And notice that this woman is now standing instead of sitting at her computer. So let's talk about some of the many benefits. We'll give one example. And one that I'm always interested in is this connection between the body and the brain. So let's use our myokine example. So you start exercising your muscle and myokines are released and they will cause the release of growth factors or other circulating factors to go to the brain and cause some changes. So here's an example of some of the growth factors that are impacted by exercise. This one, brain-derived neurotrophic factor, is a big one in the brain. And those together will increase angiogenesis, so the formation of new blood vessels, so more vascularization in the brain, and neurogenesis, the formation of new brain cells. So this idea that you're born with a certain amount of brain cells is not accurate. You're constantly turning them over. You can form new ones and form new pathways as well. And also that decreased systemic inflammation we were just talking about enhances the action of these growth factors. There will be structural and functional changes as well. So you'll have increased blood flow to the brain because you have more vessels, increased vascularization, better cardiovascular function, and less disease states that might impair vascular function. So that would impair blood flow. And so together, that will increase nutrient and oxygen delivery to the brain. And so we also can get increased brain size. So been a lot of studies documenting larger brains in kids that are very active. And also there'll be less decline with age in brain size, especially regions like the hippocampus, prefrontal cortex, et cetera. So together, you have an increase in cognitive function, in memory, and executive function. And I think it's important to note sort of what types of exercise we know impact the brain. And the one that's been studied the most and has the most positive data on it is endurance exercise. So that has a strong impact on the brain. Resistance exercise, some studies show yes, some no, a little less clear, and high intensity interval training also increases brain function as well. But what I find really interesting is this idea of enriched environment. So if you look at animal models and you look at animals who run on a wheel in the cage, they have enhanced neurogenesis, enhanced vascularization of the brain, all good. But if you take animals and you put them in an enriched environment, so now they're exercising through a maze or through an obstacle course, or they're challenged by cognitive tasks while they're exercising, then you have even augmented impact on neurogenesis and angiogenesis. So you improve the benefits on the brain. So translating that to humans, you might think about learning new activities like learning the tango or new dance moves, or learning how to paddleboard, or things where you're having to use your brain while you're being active. If you're in the gym running on the treadmill, think about trying to learn a new language while you're doing it, just to keep your brain engaged while you're moving. And then, although there's not a huge amount of data on this right now, it kind of makes sense that being outdoors does that provides you with that enriched environment. You're trying to decide where to go. You're looking where you're putting your feet. You're looking at the trees. You're trying to decide on the path that you're going to take. And so that could do the cognitive load in addition to the exercise. And so, why is there this connection between body and brain? Well, there's a theory called the adaptive capacity model that suggests that it has to do with our improved ability to forage for food historically. So while we're out running looking for food, we're using our motor cortex, so controlling our movement. We're trying to figure out how to get around the cliff and across the river. We're trying to remember, where we last saw food, where we saw the fruit, where we saw the animals, and planning that into our route. And then we're paying attention to sensory and attention details. So, a rustle in the leaves, is that a deer food, or is that a bear, a predator? And so all of these things are going on historically during our evolutionary past when we're looking for food. And so being able to enhance that process while we're moving seems like a reasonable hypothesis on why those are connected. So the acute effects are to increase blood flow, to increase myokines, growth factors, and this cognitive multitasking. So if you do this a lot, if you do chronic activity like this, you're going to improve and maintain brain function. If, however, you're inactive, then this energy conservation theory kicks in, that it takes a lot of energy to maintain systems in your body, to maintain muscle or brain or whatever. So if you're not using it, you'll spend that energy elsewhere and you get decreased brain function. So I was trying to think about what activities would be best for training the brain in this way. And I think something like orienteering would be wonderful, right? So you're out in the woods, you're trying to find different little places as you're running through the woods or wherever you are in the hills. And so it's a great combination of activities. But many of us don't actually live near a forest or in the hills. So I was trying to figure out how you could do this in an urban setting, and you could do some kind of scavenger hunt, or you could, work with your friends to try and hit all the Starbucks, in your neighborhood as fast as you can, have an espresso shot with never crossing in front of a Pete's, for example, and trying to plan that route out and move through the city. It would be kind of like orienteering in the city, the urban forage. So if we stay active forever, can we be young forever? Well, as we know, an 80-year-old will never look like a 20-year-old by physical activity alone. There's just too many changes in the hormone mixes and the way our stem cells work, and cumulative damage. That's unless you look like this guy, Bob Del Montague, age 85, looking mighty fine. He's a trainer to the stars. Might have had a little bit of work done here. I don't think this is physical activity alone. Definitely some new teeth, maybe some pec implants, but looking really good. I think all of us would just try to look that good at age 85. But most of us will not look like that at 85. And so how do we tease apart this idea of sort of how exercise impacts the aging process. And one way to do that is to look at world record times across the lifespan. So these are for masters athletes who are training as much as they can and setting world records. And here are two examples for the 100-meter and the 10K. And so looking at these numbers, let's do the 100-meter to start. So this is the lifespan here, and this is performance time. So this is a fall off in performance. You can see that, 40s, 50s, 60s, 70s, relatively flat. And then there's this point around 75 or so where you get this exponential fall off in world record times. Now, some of this could be that the faster people have died at that point, but I think it's also a physiologic finding here that after a certain point, it's hard for exercise to compensate for the aging process. And you see a similar thing over here with the 10K. Even so, it's hard to separate out straight physiology and sort of this biobehavioral idea, because if you look across species, so worms and flies and monkeys and all the way up to humans at the equivalent age for the species, there's a decrease in spontaneous activity and self-selected walk pace declines. So maybe it's that people just don't want to push themselves as hard here, but there's also probably a physiologic component as well. So there's bad news and good news. If you could put a lot of different things on this axis here, this could be bone density, muscle function, cardiovascular fitness, cognitive function. But basically you have this increase in function through childhood, 20s, 30s, there's some peak sort of in that range. And then you have a decline over your adult life and a more rapid fall off in function in the later years. And sometimes, fortunately, there's a crossover to this threshold of disability. The good news is that if you're active throughout your life, your peak values are higher, your progression, your loss with age, your trajectory of aging here will be less steep, and then you will stay above that threshold of disability. And even if you adopt exercise later in life, so you've never exercised, but after this talk, you decide you're going to do something, then you can bump that line up. You can get improvement at any age and hopefully stay above that threshold of disability for your life. Okay, so how much? Minimum versus maximum. So here are those activity guidelines I mentioned early on. This is sort of a paraphrasing of them. You want to get at least 150 to 300 minutes of moderate exercise each week. The more intense the exercise, the less you need. Resistance exercise and flexibility 2 to 3 times per week. Neuromuscular training, so balance, agility, gait, 20 to 30 minutes, 2 to 3 times a week. And the more recent guidelines have added the idea that this can be broken up into short periods, like 5-10 minute increments added up throughout the day. And they've also added this idea of avoiding sitting, which we'll talk about in a moment. So that is a lot of time. That is more time than some people have, right? So do we really need that much exercise to get the health benefits? Well, there's been a lot of data on this, and a relationship between moderate, vigorous physical activity and all-cause mortality has been established in many studies and summarized here from the Department of Health and Human Services in a slope that looks like this. So here's the hazard ratio of mortality, so death by all-cause mortality, normalized to no exercise down here, and then increasing leisure time physical activity as you go off to the right. And what's important to note here is how steep this curve is at the beginning, right? So at the low end, going from no exercise to just a little bit of exercise, you can drop your all-cause mortality by 20%. And then, it increases, you get more benefit, the benefit increases up to this recommended guidelines here. Then the curve starts to flatten out. So you're getting more fit here, but you're not necessarily gaining a lot of additional health benefits. So let's explore this idea of the low end of the curve a little bit more. Well, there was a really interesting study that came out in 2014 that compared people reporting, adults in the US reporting no leisure time physical activity in 1988. That number in blue here, if we average the men and women together, is about 15% versus 2010. If you average those numbers together, it's about 50%. So 50% of the US adults are reporting no leisure time physical activity. So remember the shape of that curve. So what that means is that getting the people on the low end of that curve, and this is a study, a single study with 15,000 men and women from 39 countries, getting these people a little bit active can have a big impact on public health and personal health. And so again, let's tease this out and see what it means. So here's the straight relationship, and here is that first steep part of the curve spread out with a doubling of physical activity at each one of these notches. And so this physical activity is in MET hours per week. So a MET is a metabolic equivalent. It's your baseline metabolism and then increments above that. So at rest, you're at 1 MET. If you were to go out and walk, you'd be maybe at 3 METs. You're increasing your metabolism above rest. So moderate exercise might be 6 or 7 METs. 10 to 12 would be vigorous activity. So this first drop, where you get a benefit of 30%, is 0 to 5 METs. So here's some example of MET hours. So walking briskly at 3 miles per hour is 3.3 METs per hour. So that means to get that 30% benefit, you'd have to walk maybe an hour to an hour and a half a week. So that's 10 to 15 minutes a day to decrease this all-cause mortality. And then as you go up and do more activity or add more on here, then your curve continues to slope down until it starts to plateau down here. So not that much activity to get a major benefit in your overall health parameters. The more intense the activity, the less you have to do. So I'm sure many of you are familiar with the most popular fitness fad in the last 5 years, high intensity interval training. So this is an idea of high intensity separated by low intensity. So going up and down, and there's all sorts of protocols. There's 30, 20, 10, there's 2 minutes on, 4 minutes off, 10 seconds on, 10 seconds off, all these different things. They all seem to work. The key is intense exercise separated by a rest period. So you have this up-down thing. You can go into the physiology during question and answers, but you're tricking your body into thinking you're doing more work than you are, and you're able to push yourself hard in those higher intensity bouts. So it's a time-efficient way to improve your Vo2 max, which we talked about, endurance, mitochondrial mass and function, and health. It's important to periodically push that upper limit, because as you age, that maximum declines, and that means that every submaximal activity you do, walking to the grocery store, will feel harder and harder if your maximum's declining. So you want to try and keep that up and keep pushing that upper limit. So what about the opposite extreme, sitting? So a lot of news on sitting, perils of sitting, sitting kills, sitting is the new smoking, right? Very dramatic. But what do we really know about sitting? Well, on average, adults in the US sit over 9 hours a day. It's an independent risk factor for disease, meaning if you control for other factors like obesity, smoking, diseases, sitting more increases your risk factor for all-cause mortality. Prolonged sitting impacts your body mass index, so your adiposity essentially, fats, glucose, diabetes, cardiovascular disease. So as I'm standing here, I'm using my postural muscles to keep me upright. And that uses fats and other fuels in your body and changes what's going on in your metabolism. If I'm sitting very relaxed, I'm not doing that, and it has a spiraling effect. Interrupting sitting may help, and outside activity is only partly protective. So I wear a Garmin watch. I've been wearing it for about 10 years. And when I first got it, I'd go out for a cross-country ski for 4 hours, and I'd come back and I'd be having lunch, and an hour later, bzz, it would buzz, and like, what? Tell me to move. What, 4 hours isn't enough? But it turns out that my watch is very smart, and it knew the literature, and it knew that my outside activity wasn't necessarily protective through the rest of the day, and I needed to be thinking about these things throughout the day. And that's been sort of synthesized in this Health and Human Services figure here that shows that you may be meeting the guidelines here in moderate to vigorous physical activity, so you're in this green zone. But if you're sitting the rest of the day, you lose some of those benefits. You drift back up into this yellow or even the orange zone if you spend the rest of the day sitting. So you need to think about what you're doing outside of your exercise bout. You can't just run in the morning and then sit on your laurels, rest on your laurels the rest of the day. You need to keep getting up and moving around throughout the day if you want to maximize those health benefits. And not all sitting is the same. So if you look at the Hadza tribe in Tanzania, the hunter-gatherer tribe, they're sedentary 10 hours a day, office worker 9.5. But look at the difference in how they're sitting. So in this tribe, they're sitting upright. They don't have a backrest. They're squatting down. They're using their leg muscles. They're digging. They're setting fires. They're preparing food. And so it's an active sitting. In the office, we often sit like this, leaning back, not using any of our muscles. So those are two very different things. In addition, the Hadza get about 20,000 steps per day outside of their sitting time, whereas the average US adult only gets about 4,500 steps per day. So a lot of differences there. But even just sitting on a Swiss ball or getting a standing desk and mixing up your Zoom calls up and down would be beneficial. So the bottom line is that these lifestyle activities or even short, intense activities can really help. So these things add up throughout the day. So don't just ignore them as not being significant. One example I like to share is that if you compare the strength of Hadza women with US young women, so young Hadza women with US women, the strength is not really that different. But over the lifespan, women in the US tend to lose strength more rapidly. So the Hadza women are still strong at age 70, whereas in the US, that's not the case because we're not doing these activities of daily living. We have much more convenient lives and aren't maintaining that strength just by moving around. Okay, so let's look at the opposite extreme. So what about too much exercise? Well, this will only affect about 2 to 3% of the population. But I think it's worth mentioning because it is an interesting new phenomenon or new discovery, essentially. So this is the traditional view of, the low end, you have the biggest improvement. So the health risk is low versus high, and you reach this point of maximum benefit. But more recently, they've added a tail end to that, so a reverse J curve. So after a certain point, some of the benefit of physical activity may be lost. Now, the question is, where is this point? And likely it's different for different people, different styles of training. Some people cited it 4 to 5 hours of intense activity per week, but this is really unknown at this point. So what we do know is this is only really relevant probably for people over a certain age, like over 45 or 50. So when you're younger than that, your repair mechanisms are very robust, right? So you could compensate for very high levels of intensity and duration. There are these blood markers of cardiac damage that come out after prolonged races like marathons or ultra endurance races, but not in everyone, right? But it's an indication that your heart is struggling. Atrial fibrillation has been shown to be higher in very, very heavy exercisers throughout their life. Maybe some scar tissue, some calcification. It's unclear what the clinical repercussions of those might be. And not everyone responds this way. So are there differences in genetics? Are there differences in styles of training? Like one group's not getting enough recovery time for their heart to recover or not. And the data is just not that robust because there's so few people in that category that when you do these population studies, there's a lot of sort of strange statistical artifacts. But it doesn't surprise me because our bodies like moderation, right? So water, critical to life. You can kill yourself by drinking too much water. Red wine, good for us in small amounts, not so good in huge amounts. Exercise with overtraining. So it doesn't surprise me that we need that recovery time in order to get the most benefit out of our physical activity. So that means that training for performance and longevity are two different things. And an analogy that I heard from James O'Keefe, who's done a lot of work in this area, which I really like, is this comparison between a Formula One car and a Honda Accord. So a Formula One, it's souped up for power, it's fast, it's strong, but it burns through 3 engines in a season. onto a cord, you put a little oil in it, you clean it off every once in a while, it can go and go for hundreds of thousands of miles without breaking down. So those are the two comparisons to performance and longevity. Just a couple more slides. My recommendations for training for performance then are focus training, right? So you're doing one thing, the specificity of training, you're doing progressive overload, you're doing more and more in that one thing. But even so, there's a training regimen now that's emerging as being more effective and better for you, which is 80-20. So 80% of that focus training will be at a lighter workload, 20% will be more intense. It allows your body to adapt, but still have recovery time. So it's better for your performance and for your health. So the advantages of training for performance is that you'll be strong, fit, you have increased health benefits relative to sedentary people. You'll have a sense of accomplishment, self-esteem, there's social interaction when you sign up for races, you'll look great in Lycra maybe. Disadvantages is that you may give up some health benefits relative to sedentary, and there's an opportunity cost for this. So if you're focusing on one thing and being the best you can, that's fantastic, but it means you're not doing some other things. You may not be getting well-rounded fitness. You may not be spending as much time with your family. You may not be playing tennis or, pick up basketball. So you are choosing to do one thing instead of more things. And that for some people is an opportunity cost. Recommendations for longevity are a little bit different. So you meet the physical activity guidelines, so moderation, with some bouts of high intensity exercise to keep that high intensity up. You move throughout your day and you reduce your passive sitting as much as possible. You try a variety of activities, you add some resistance training, and you get outdoors and be social and play as much as possible. The advantages here are a compression of morbidity, so less time spent in those later years of potential disease state, and maybe an increase in longevity, so longer life. You enjoy movement and life more, you have increased function, you'll be able to hang out with your grandkids, and independence for longer in your life. Disadvantages, won't win any marathons probably, and life may be less convenient. So what I mean by that is that in order to get this activity throughout your day, you'll have to make choices where you take the stairs, where you don't use your car, sort of reverse engineering that convenience out of your life to get that movement back integrated into your life. So in summary, your body is watching you and it's paying attention to both the big stuff and the little stuff. So to age well, you want to move regularly throughout your day, do it with others, and play whenever is possible. So remember, a convenient life is not necessarily a healthy life.
Wow. Anne, Dr. Friedlander, thank you very much.
You're welcome.
I'll have a chance to give you at least visible applause at the end of this evening. But we want to get to some questions. They have been growing in the chat. I just want to make a comment here that about 10 minutes into your talk, I had a sense of what is coming, and I used the spring-loaded lift on my table. So I'm now standing in front of my computer. I
actually saw you do that. Yes.
At least I
check one person.
Oh God.
And Laurie too. So,
oh yes, Laurie, yeah. Excellent. Okay, I'll try to go in order here. Don't forget, you can ask the questions yourself. You don't need to trust me to read your questions well. Just please raise your hand. And then when the time comes, when you're acknowledged, please unmute yourself. And if you dare, make your camera work, your webcam, turn it on, and ask your question yourself. But here we go. Steve from Marin asks, he's talking here about, let's see, why might a person actively exercising all his life with low blood pressure, good diet, why might that person still develop cardiovascular disease? Develop a narrowing of the heart arteries requiring bypass surgery?
Yeah, so unfortunately, physical activity can't really cure everything. And there are people with a family history of cardiovascular disease where it can still approach, I don't know what the cholesterol levels are in this person, but you can still have the development of disease. What you don't know from that example is how bad it would have been if they hadn't been exercising. So it's possible, like if they have a family history where someone had a heart attack early on in life, that they delayed the onset of that disease. So in many cases, you can't completely prevent the development of disease, but you'll delay the onset and minimize the impact of that.
And Anne, might the answer to Patricia Barrera's question be similar? She asks, why do some people that exercise and are fit nevertheless get cancer?
Yeah, so there are certain cancers that are definitely impacted by physical activity. So you reduce the risk. I mean, a lot of it has to tie in with, there's a connection between insulin sensitivity and cancer. So if people are becoming insulin resistant, it can have an augmenting effect on tumor growth. So physical activity can pull that back. There are many, many factors that go into the development of diseases. So, epigenetics, diet, genetics, and physical activity. So physical activity is always helping, but not always completely preventing.
Thank you. Chip Gribble asks, could it be that outdoor exercise is more beneficial than indoor simply because of enhanced oxygenation?
So that's an interesting idea, but there really is no enhanced oxygenation. So the way the gases mix in the air, there's going to be about 20% oxygen, whether you're inside or outside. And so you're going to be getting the same diffusion of gases into your lungs. I mean, maybe when you're outside, you're inspired to take deeper breaths rather than in the gym where you're next to someone that smells. And so you're not breathing as much, but the oxygen content inside and outside should be the same unless there's something wrong with the ventilation system in the gym.
Great. I'll come back to Werner Haag here. Let me just ask a question from Krista Lotto. How do you know what your heart rate needs to be to help you when you're doing interval training or any other type of exercise? That is what your heart rate needs to be.
Yeah, so the interval training is actually an easier question to answer there, because ideally the interval training, to be really effective, you want it to be as intense as you can handle, right? So, for someone that's really fit, that might be doing intervals on a bike inside as hard as you possibly can. Now, these are very short intervals, so they'll be like maybe 20 seconds. So you're just pushing yourself, and then you're resting for maybe even up to 2 minutes, then you're doing it again. So it doesn't really matter what your heart rate is there, because it'll ramp up, and really it'll almost, before it reaches its peak, you'll already be in your rest period. Even if someone is, maybe older, a little less fit, and they're doing it with a walking program where they're, walking rapidly on one side of a block and then slowly and then rapidly and then slowly, really you're just trying to push yourself out of your comfort zone. And so it doesn't matter so much. In terms of cardiovascular fitness, there's a lot of literature that you can look up on training zones. And so the sort of generic advice would be, the talking test. So periodically you want to be able to exercise to the point where it's difficult to carry on a conversation. So you're kind of breathless, and that'll correspond to about 65% of your maximum or higher. If you really want to drill down to your heart rate and you have a heart rate monitor, then you can do a test where you walk up something steep as fast as you can and see what your maximum heart rate is. And then you want to develop your training zone so you're at about maybe 70% of maximum periodically, but also doing a low base of training where you're down, where it doesn't feel that strenuous. So that you're doing the high intensity training, but you're also forming a base lower down. And so if you look up zone training online, there's a lot of good resources there that can give you specific heart rates for your age.
Thank you so much. That was so helpful.
Oh, good.
I see a hand raised here. All right, Werner, please unmute yourself and fire away.
Hi, that was a great talk. I really enjoyed it. I just want to say I've been an athlete for most of my life. I'm also a scientist, but I just got back. I'm 65 and I just got back from wrestling practice.
Nice.
My experience has been very much exactly what you've been saying here. So it really agrees with that. I would say I didn't know about the sitting. So I do a lot of sitting and eat a lot of chocolate. So I'm going to have to work on those parts.
Is it dark chocolate or milk chocolate?
Dark chocolate. Yeah.
Dark chocolate is actually kind of good for you.
Yeah.
Vasodilator, just not in excess, but.
Right. Well, yeah, okay. I won't go there. But I also wanted to mention that I'm the membership guy for the Bay Area Orienteering Club. And there are orienteering clubs all over the country. And so we do events all over the Bay Area. There's lots of parks around. So even if you're living in the city, you can still get out there. Here in San Jose, we're lucky you're just a few minutes from a park, no matter where you are.
That is great news. Thank you. I will actually add that to my next talk. Maybe I'll give a little link and people can go directly. You want to improve your brain? Go to this club.
There you go. It's right there. Yeah.
Nice.
Thank you.
Mm-hmm. Thank you, Werner. Let's see. Rakesh Bharadwaj asks, can you talk about the difference between repetitive exercise, say in a gym, as opposed to goal-oriented activity, farm work, construction, etc.?
So in physical context, whatever type of physical activity you're doing that'll keep you doing it is the right kind of physical activity, right? So it doesn't help to do exactly, what's optimal for your body if you're not going to keep with it. So if you like going to the gym and, walking on the treadmill or doing whatever, then that's great. If you like working outside and that's going to keep you moving around, that's great. Now, the thing I like about the outdoor work is A, it's outdoors, and B, and I think maybe this is where you're going with the question, is that it is whole body, it's multiple joint, and it gets a lot of different stabilizing muscles and things that you might not get if you're on a machine and you're doing, bicep curls, right? So it's the functional workout that people are trying to incorporate more of. So, the CrossFit, the paleo workouts, all these types of things where you're actually doing work, you're accomplishing something, and you're using your whole body to accomplish that. So there is a really strong benefit to doing that type of work.
Thank you, Anne. Earlier on, some character named Tucker Hyatt asked a question concerning inflammation, that systemic inflammation is always a bad move. Avoid that if you can. But to occasional or specific locations of inflammation in your body, that inflammation is almost always beneficial. And yet, aren't we told that to use ice, for instance, to decrease that sort of even localized inflammation? Could using ice actually inhibit healing?
Yes. In fact, that has been the dogma for so long, that you want to inhibit inflammation. And there are certain cases where that is still useful. So if you have an acute injury and you've got to move the next day, or, it gets so swollen that the joint, is causing additional damage in the joint, then reducing the swelling could be beneficial. But there are a lot of studies emerging now that suggest that icing may actually impair the healing process. So it actually takes longer to heal. And so there's been this transition in the last 2 years or something, maybe away from icing. And this is especially true for athletes who kind of ice out of habit. Like, they come back, they're afraid they're going to be sore. They have another workout the next day and they jump in the ice bath. And what people are finding is that may reduce pain a little bit acutely, but it may also reduce like the hypertrophy process. So the process by which you get stronger, and the adaptation to the exercise you're doing may be inhibited. So I would say on that, stay tuned, but people are thinking that may not be the best idea now.
All right. Thank you, Anne.
Mm-hmm.
This may be our last question from Mike Vandeman. My favorite exercise. Wait, no, I skipped one here. Let me see. Oh, here you go. Okay, we'll go back to Mike in a second. Mike Vandeman asks, my favorite exercise is reading while hiking. It saves time. What am I missing by not exercising every muscle?
So reading while hiking, I hope you can catch yourself when you trip on the rocks. I hope you're doing audible. You're listening to books while you're hiking. So I'm not sure what you mean by what am I missing by muscles. get a little resistance training in there in addition to your hiking to get that upper body strength up.
Okay. And Rob, here's our last question. Rob said, you listed a benefit of exercise for depression. Could you briefly describe how that mechanism might work?
So, yeah, there's been a fair amount of data suggesting that regular physical activity can be equivalent in some people to medication for depression. And it has to do with the changes in the brain chemicals in the brain. So the opioids, the cannabinoids that actually you can form in your own brain, all of these can change the brain chemistry and increase or decrease depressive symptoms. Also frequently associated with physical activity, often it's a social event, so you're with other people. There's a sense of mastery, of improvement. So there are sort of social and cognitive benefits, but there's also brain chemistry benefits. Increased blood flow to the brain, all these things can impact depression, anxiety. It's a great anxiety reliever. I use it certainly to relieve anxiety. And so all of those things can impact mood and such.